So for those of you who had a quick coffee and came back early, you get an exclusive start to the presentation. This presentation is looking at some of the results from the second work package I described earlier, focusing on neonatal mortality in pigs. I said I would explain a bit more about why I call piglet mortality a production disease. And I call it that because it fits the definition. First of all, it's a problem which persists in intensive production. So you can see from this graph that as the litter size born alive has increased over the last years, the percentage of the piglets which die has hardly changed. We've made no improvement. And in fact, in real terms, that means more piglets are dying now than were dying 10 years ago. The second thing which makes it a production disease is it's a problem which increases with the intensity of production. This graph shows the data from Interpig, the EU cross-country comparison. And you can see that the countries which have achieved better litter sizes tend to also be the countries which show higher mortality of piglets. Two interesting outliers on here. No, looks like I'm not getting a pointer. Okay, up at the top you can see Sweden, who seem to have a much higher mortality for their litter size than you expect. Interesting that Sweden are the only country on this graph so far who have banned farrowing crates. So that's another challenge we have to think about for the future. If we look down at the bottom end of the graph, we can see Brazil, who, although their litter size is not great, have a very much lower mortality than we might expect. What do Brazil have that we don't? I suspect it may be a lot of cheap labour. So as we have to move towards higher welfare farrowing systems, and as we have to manage more animals with fewer people, our challenges for piglet mortality are going to increase. The graph showed the mortality of piglets born alive, but we shouldn't also forget the piglets who never get that far. These are some data from a survey done in the ProHealth project in different countries, looking at the levels of mortality. And you can see in those countries the number of piglets lost through stillbirth are very significant, sometimes almost as high as the number born alive but dying before weaning. When you add those two things together, we can see losses of 1 piglet in 5 of every possible piglet that we could take to market and sell. That's a huge economic loss. When we start to think about piglet mortality, like all production diseases, we can see it's a very complex issue. The different causes of death of the piglets, chilling, crushing, starvation, infection, are all tied together in a complex way. And we can see 3 big influences which affect how much those are expressed. We have the quality of the piglet itself at the time that it's born. We have the maternal quality of its mother in terms of behaviour and colostrum provision. And we have the quality of the environment into which those piglets are born. Again, all of those things interact to determine the final level of mortality that we see. We've talked several times about the fact we've changed ourselves a lot in recent years with selection for much more prolific animals. And so one of the things we wanted to do in the ProHealth project was just to look again at the overall mortality issue and what the important components were. In collaboration with French partner CCPA, who are a commercial company in France supplying piglet feed, but also supplying technical services. They had a big database from farms in France with mortality problems who had submitted piglets to them for a detailed post-mortem analysis of what the true cause was. So from 146 different farms, a random sample of sows was taken, and every piglet that died on those sows went into the lab for an analysis of what the true cause was. In total, you can see more than 7,000 piglets now in their database. And I think what those data showed was quite interesting. Okay, without the pointer, I have to try and describe a bit better. The yellow segments on this pie chart are the piglets who died from what we used to think of the important conventional causes, crushing, starvation. And you can see they only make up about 13% of all the deaths. When we start to look at the grey segments, these segments are the deaths that actually started even before the piglet was born. So piglets who die during farrowing, piglets who are born alive but non-viable, piglets who are born with signs of intrauterine infection, and that was one that surprised me, or piglets who died in utero and are born mummified. When you add all those together, you're approaching 2/3 of all the deaths, which you can say, to deal with those, we should have started way back in gestation. By the time of farrowing, it's too late. Something else we were interested in this study was the differences between different farms. We wanted to see if there were particular patterns of mortality that we saw in different farms. Starvation and crushing always seemed to go together. It seemed like, as in the earlier complex diagram, they're basically the same mechanism with just different endpoints. They're very highly correlated within the farms. They show the same patterns of increase in parity. But when we look at the pattern of the other causes and start to play statistical games, we can see 3 different types of farms emerged. The first farm, the column on the left called cluster 1, you can see there has a higher proportion of deaths due to the red crushing and the blue starvation. And you can say these are the farms who should be paying more attention to their management of the newborn piglets, getting a better environment in their farrowing house. The second column, cluster 2, you can see has a big purple segment. These are the ones which have a high proportion of their deaths down to piglets dying during the farrowing process itself. So these are the farms you can say they should be looking at their farrowing management, their intervention. Are they doing their induction correctly? Have they got the right condition on their sows? Things like this. The third column, cluster 3, on the right, you can see they're the ones that have the big orange and light blue proportions. And these are the piglets who are mummified before birth, so they died in utero, or the piglets who are born with very low birth weight, low viability. And you can also see these are the farms that have the bigger litter sizes and the lower weight piglets. So here they have to look for different solutions. They again have to go back into pregnancy, possibly even back as far as the previous lactation, because we know that the causes of these low birth weight low viability piglets actually start quite early, and that's something I'll come back to in a bit. So then, within the project, we were starting to look at different factors which might be having an influence in explaining these differences between different farms in what was going on. Our colleagues in France at INRA and CCPA have been focusing on the influence of the gestation housing system. And you might at first think, that's really strange, we're talking about piglet mortality, why are we looking at gestation housing? But they've done a number of experiments now where they've compared sows kept in conventional slatted group house gestation systems with sows in more enriched bedded gestation systems. All of the sows go to the same conventional farrowing accommodations, slatted floors and farrowing crates. But what they see repeatedly is the sows from the more barren gestation system have a higher early piglet mortality. In this particular experiment, you can see the difference between 12 and 72 hours after birth, 6.3 against 13.6% of deaths. And this is not just one study, they've now seen this time and again. Within the project at the moment, they're trying to understand what the cause of that is, what's been changed. They have seen that the sows in the conventional systems have higher stress hormone levels. That may be having an influence. But they're now looking in much more detail at things like, is that influencing the maturity or the vitality of the piglets or the immune transfer process? And if so, what might we do to those conventional systems to improve the situation? Another thing which is different between different farms is the management of the sows. And our colleagues in Denmark at Sedges have been looking at how the interaction between people and sows might influence piglet mortality. They're interested in whether, by the way in which sows are managed from their entry into the farrowing house, can change them in ways that will be beneficial once they give birth. So just in the 5 days between housing and farrowing, they looked at the effect of getting a better human-animal interaction. Each day when they went to clean the pen, they just had a bit of friendly interaction with the sow. They also looked at maybe they should play some nice soothing classical music in the farrowing house to keep their sows calm. And you can see the sow in the pictures, quite an appreciative music lover. Interesting also to note at the bottom of this slide, we're now talking about very prolific sows, total born averaging over 18. And these are sows in loose farrowing systems, because in Denmark, they're looking into the future and saying, probably the farrowing crate will have to go. We need to develop solutions and alternatives for when that time comes. What did they find? What they found was that even just 5 days of getting to know your sows better had a marked influence on how those sows behaved. They were much less fearful of people. Classical music, the people who worked in the farrowing house said they thought it made the sows much calmer. We couldn't really show that with our experimental data. So the people on the ground were convinced, the scientists weren't so convinced. But the important question is, what are the implications of these changes to sows for piglet survival? And that's something which we're following up at the moment in some larger scale trials in Belgium. What else is different between farms? Well, plainly, the sows themselves are different between farms. And in Newcastle, we're working with a breeding company to try and look at how different characteristics of individual sows affect the risk of mortality. Two things that we would highlight that are particularly risky are how the sows move and how often they move. So what we really want are nice, quiet, calm sows who are not restless and who, if they do stand up and lie down, do so in a very controlled way. Just to illustrate that, on the next slide I have a couple of videos which shows the sort of differences we can see between individual animals in their lying style. Sow on the left has a very controlled way of lying down. Sow, oh, she's gone already. Sow on the right, quicker than you can blink, just flop down really quickly. You can imagine if there are piglets there, one on the left, they have a good chance of seeing what's coming and moving away. One on the right, they've probably had it. Now, if you have very good eyesight, you can just see on the back, above the tail on those sows, a little square of material. What's that? We wanted to find a way of trying to characterize how sows change posture. Obviously, we could sit in front of a video camera for several months for each sow and do it the hard way. But actually, we quite like technology. So what was under that little square was an accelerometer. It's about the size of a matchbox. And what it can tell us is a complete record for that sow of every movement, what the direction was, what the speed of that movement was. So, like our aeroplanes, the sow has possibilities to move in 3 dimensions, and the track we get from this accelerometer that you can see in the picture shows for that sow how she was moving. With some very clever computer scientists, I don't pretend to understand how they do it, but they do it very well. They can translate a trace like that and tell me what was the posture of the sow at every minute, what was the posture change, how fast did that change happen, was it smooth or jerky? And that's the information that we're now using to try to understand what things are risky for the crushing of piglets and what things make sows more or less good movers, we can say. So we've gone off to a big multiplication herd, spent a year there, putting these accelerometers onto sows while they farrowed, getting records about those sows of what was the flooring they were on, what was their age and their size, did they have good leg conformation, how were they moving, and did they actually crush any piglets or not? And that's the database that we're looking at now. So for each of our sows, we have a very detailed description of the quality of their front leg and hind leg conformation, and what crushing happened. In total, we've got more than 400 sows with this data set now. A bit more than half of those managed not to crush any piglets. That was quite good. But a bit more than a quarter of them managed to crush more than 2, so those are our bad cases. What was different between the ones who crushed and the ones who didn't? We've looked at it 2 ways. First of all, we've said, does the sow crush anything or nothing? So a simple yes-no question. And what did we find there? Well, the age of the sow had a bit of an effect. The biggest influence was what her litter size was. The more piglets she had, the more likely she was to crush somebody. When we started to look at the lying data, it got a bit complicated, because what we found was not a simple answer of this leg conformation or this style of lying down. They seemed to interact in quite a complex way. So depending on, for example, the shape of the hind pastern, how risky the speed of backwards and forwards movement was, had different consequences for piglet mortality. And at the moment, we're scratching our heads and working with this data set to really try and interpret what that means. We move to the higher level and say not just did she crush or not, but how many piglets did she crush? We see some similar things. Again, there's an effect of parity, but it's not as simple as just the older they get, the more they crush. The pattern wasn't consistent. Some parities seem to be worse than others, but we can't always explain why that would be. Litter size certainly still had a very big effect. Surprising to me, the thing which came out in the leg conformation was the shape of the front leg. If they had a good straight front leg, then they crushed fewer piglets than if the leg was either buckled or sickle-shaped. I would have predicted the back leg would have had more effect, but our data is telling us it was the front leg which was important. We can speculate why that might be. Maybe something to do with how they kneel when they lie down. If we move to our accelerometer data, again, interesting things are going on there. So what we saw was the faster the front end goes down, the more piglets she crushes. The faster she flops down in total, the more piglets she crushes. And again, some complicated interactions between the leg conformation and some of the other accelerometer measures. So this is still a bit of a work in progress, and we're doing two things at the moment. We're trying to look at these accelerometer characteristics in a more sophisticated way to understand exactly what the posture change is that causes the problems for particular speeds of lying. We're also interested in actually whether this is something we might start to think about as a selection criteria for sows. Our very early analysis suggests that this thing I'm calling lying style is actually a heritable trait. Whether it's working through other things like leg conformation, we don't yet know. We're still looking at those questions. But we may have a way forward here to actually select sows who are more careful mothers. And it's interesting, in a genetic study we did a few years ago, when we looked again at a line selected for good survival against a control line, what we saw was the line selected for good survival seemed to be a more careful lying down mother. So exactly what the gene is, I think we'll take a long time to find out, but I think there's something there that's going to be of interest. So much for the mothers. What about the piglets? We all know that as we've increased litter size, we may get more piglets, but we get poorer quality piglets. We get an overall reduction in birth weight, and we get more variability within the litter in birth weight. Both of those things are not really very desirable for us. What is a low birth weight piglet? Well, one of our students a few years ago did a big analysis of some breeding company data sets. What she found was that any piglet with a birth weight less than 1.25 kilos had a significantly higher risk of below average lifetime growth. That figure seems to be something that's been coming out in a few other studies as well. In our data set, something approaching a third of all the piglets born were below that threshold, certainly well over a quarter. So we're talking about a lot of piglets here who are possibly suboptimal in terms of their lifetime performance. And if we look at the old data on birth weight and mortality risk, like this German data set, again we can see 1.1, 1.2 kilos seems to be the point at which risk of mortality starts to increase very rapidly. Again, some similar data I've seen recently from Spain and the US, coming up with a fairly similar figure. that we put a lot of focus on birth weight. I'm not sure that's really the whole story. These two piglets in the picture are exactly the same birth weight. But I think all the producers amongst you would probably say, I know which of those two piglets I'd rather have in my litter. They may be the same birth weight, they're not the same. Why are they different? We have this phenomenon, which for the rest of my talk I'll call IUGR, because it's a mouthful. It stands for intrauterine growth retardation. These are piglets who haven't grown normally because their nutrient supply through the placenta in the uterus at some point became suboptimal. How do we know that? We know that by looking at their head shape. And the reason the head shape is different is that if the piglet's short of nutrients, it prioritizes its brain. So it will always look after its brain first, and the rest of the body can sort of tag along behind as best it can. That means these piglets get born with this characteristic big domed head relative to the size of their body. And you can see that's what's different between these two pigs of the same birth weight. One is small but perfectly formed, we might say. The other one has this characteristic domed head that says it was short of nutrients at some stage before it was born. How much does that matter? Well, again, we went back to our collaboration with JSR and our year of data collection on one of their farms. We collected data on more than 20,000 piglets, recording their birth weight, but also their head shape and their subsequent cause and time of death if they died. What did that tell us? What that told us was that these IUGR piglets, on a like-for-like birth weight basis, had a higher probability of mortality. Particularly, the smaller they were, the more damaging this IUGR characteristic was. So we're saying, well, if we're going to be selecting for more and more piglets, it's actually going to be quite hard not to have piglets who are lower birth weight, but can we at least try and get piglets who, if they are smaller, are appropriately mature? Can we find some way to get fewer IUGR piglets? Is it a heritable trait we could work with? And to ask this question, we've taken two approaches. First of all, we said, well, could we just select piglets who are not IUGR? So we had a look at our data set, and the answer is not really. The heritability of being an IUGR piglet is very, very low, too low to really work with in a genetic improvement scheme. Compared to birth weight, the heritability of birth weight, 0.18, you can do things with that. There is a correlation between those two things, so if we selected for heavier birth weight, we would at the same time expect to get fewer IUGR, but we can't get there directly. So we abandon that one. If selecting at the piglet level isn't practical, can we take another approach and select at the sow level? Maybe this IUGR characteristic is not something inherent to the piglet itself, it's a problem with its mother. Its mother didn't provide a good enough uterus for it to grow normally. So we looked again at our data set and we said, let's have a look at some of the sow characteristics, in particular, the proportion of IUGR piglets she has in her litter. Also, what's her average birth weight in the litter, what's the variability of birth weight in the litter, and what proportion of that litter then actually survive. What did we find? When we look at the sow level, the heritability of this IUGR characteristic, 0.19, that's something that geneticists could work with. And if we selected for that, we would expect to get significantly better survival. That's what the genetic correlation tells us. It's not as good as the heritability of average birth weight, but the two together are going to be very important, I think, in the future in delivering viable piglets. The two things are correlated, so if we select on both, they'll benefit each other. Interestingly, when we look at the variability of birth weight, that also has a heritability which is workable with. So we start to have a number of genetic tools that we might employ. But we're going to have to be careful, because all of those things we want, the good head shape, the good birth weight, the low heritability of variability in birth weight, all have adverse genetic correlation with litter size. So we're working against ourselves the whole time. If we select the bigger litters, we expect all those things to get worse. If we start selecting for those things, we have to be a bit careful we don't take litter size too far back in the wrong direction. But ultimately what matters is not how many piglets you have born, it's how many piglets you wean. And I think we maybe put too much emphasis on numbers and not enough on quality over the last few years. So what do we conclude from all this? Well, we can conclude that piglet survival is impaired by large litter size and low birth weight. Nothing new in that, we've known that for a long time. We now know that this IUGR characteristic has detrimental effects over and above just birth weight. And we now have a very simple marker of IUGR in this head shape that we could apply very simply in selection procedures on farms, and it has sufficient heritability to make some reasonable progress. So selecting against this at the sow level, I think, could be a good way forward. And it's something I think our breeding company partners are now having a look at in other data sets. So summing up our work package as a whole, what do we say? Well, piglet mortality is complex, everybody's known that, and it's quite intractable, so it's a true production disease. The farm environment, the sow characteristics, the piglet characteristics all make their contribution. And looking into the future, the more we select for prolificacy, and the more societal pressures ask us to adopt more welfare-friendly farrowing systems, the challenge is going to become greater. So within ProHealth, we've been having a look at all levels at this. We hope we're increasing scientific understanding, and we hope at the end of it, we will actually see some practical solutions emerging. Thank you very much.